We are going to look at an example of evaluating a function using its graph. The function that we have is a piecewise function. It has gaps in it. There's a piece, and another piece, and another piece. Notice that it is a function. It does pass the vertical line test because I can draw vertical lines anywhere, and there's only one value or no value. Notice here there is an open circle and a solid dot. The solid dot is a point and is part of the graph. The open circle represents a point that's not there. So there is no point right here at -4, but there is one right above -4. Notice there's a gap right here as well. So it is a function. When we go to evaluate a function, given f of -3, for example, remember f of x stands for y. So f of x is another way of writing y. So what I'm asking for here is, what is y equal to? Well, when I'm asking what is y equal to when x is -3. So I'm going to find x equal to -3 on the x-axis. Here it is. And I'm going to go up until I touch the graph. And notice that the point -3, 1 is actually on this graph. When x is -3, y is 1. So I say that f of -3 equals 1. And that indicates that the point -3, 1 is actually a point on this graph. So I've evaluated it. Okay, let's try f of 9. For f of 9, I'm going to go across till I find the x is 9, and here's a point right up here. And I look across, and the y value is 2. So f of 9 is 2. And notice the point 9, 2 is a point on the graph. So the x is inside here, and the whole thing is y equals to 2. So I'm asking, what is y equal to when 9 is the x? Okay, what about when f is -4? If I look right here, -4, I go up and I see there's a circle here, so that's not really a point. I keep going, and up here I see there is a point. It's a solid dot, and its value is 7. So f of -4 is equal to 7. What about f of 4? Here's f of 4. Here's x equal to 4. Notice this time I have to come down. It is a solid dot, so it is part of the graph. The y value is -2. So f of 4 is equal to -2. What about f of 6? Come over to 6, and I go up, but that's an open circle, so there's not really a point there. So there is no value. I would say 6 is not in the domain. So what I'm going to write as my answer is DNE, which stands for does not exist. There is no value. I wouldn't really say not applicable, because the question is a good question. The answer just happens to be undefined. That would be another thing you could write, does not exist, or you could write undefined. Okay, what about f of -8? Here's x is -8, and I go up, and there's a point right there, and it's 3. So f of -8 is 3. What about f of -11? I come over here. Again, there's that open circle. There's nothing there, so there is no value. I could say -11 is not in the domain. It has no corresponding value. Okay, let's try and find f of 5. Here's 5 on the x-axis, and notice there's a gap here. There's no part of the function above or below it. So it also has no value. or I could say it does not exist. Now sometimes rather than evaluating the function, we go backwards. We say, for example, given f of x is 5, find x. Well, notice when we're using a function, when we're evaluating the x's to find the y's, there can only be one answer. There's either one answer or does not exist. But when we go in the reverse order, when we're given y, then there could be more than one x. There could be no x's, there could be one x, or there could be more. Remember, f of x is another name for y. So what we're really saying here is given that y equals 5, what is x? So I'm going to come up here and I'm going to find y equal to 5. So let's kind of make a red line there. This is not a point, so that does not count. This is a point right here, so x could be negative 5. Notice this is a point right here too, so f could be 7. So there's two possible answers for x if I'm looking for y to be positive 5. So I don't put any parentheses or anything because this is just a list of the possible answers. X could be negative 5 or x could be 7.